Hello everyone, welcome to today's video lesson. Today we are discussing 11.5 day 1. We've already done areas of sectors. Now we're doing area of segments, and it's going to be awesome. Are you ready? Here we go, area of segments. Let's first define what a segment is. A segment of a circle is a region of a circle bounded by an arc and a chord. So we talked about what a sector of the circle was. A sector is bounded by a central angle. So whatever this angle is, all of this right here is the sector. So now we're on a segment where it's bounded by an arc and a chord. So here's the chord, here's the arc. So the region or the segment of the circle is that spot bounded by the chord and by the arc. That's what a segment is. And today in this lesson we're finding the area of the segments. So this one says find the area of the shaded segment, round your answers to the nearest hundredth. And this should have been filled in. Sorry about that, everybody. This right here is what we want to find the area of. Okay? That blue region right there, and we call that a segment of the circle. So what we're going to do here, class, our strategy is we're going to find the area of the whole sector, and then we're going to subtract this green triangle. If we find the area of the whole sector and subtract the green triangle, that would just give us the blue segment. Okay? So let's first find the area of the sector. The area of the sector is n over 360 pi r squared. So our n is the number of degrees, 94 degrees. So 94 divided by 360, pi times the radius squared. And the radius is 5. So if you do 5 times pi times 94 3/60ths, you should get the area of the whole sector is 20.51 approximately. So there's the area of the whole sector. Now I want to subtract the area of the triangle. So here is my triangle. I want to subtract that. Okay? So when I draw the height of the triangle, the height is right here and the base is right here. I'm just going to kind of draw this out a little bit more so I could see it better. This angle is half of the central angle, which is half of 94. So 47 and a half, I believe. Oh, 47. 47 degrees is the angle of half of that triangle. And then the base right here and the height right here, we know that the radius is 5. So now I could use trig to find the base and the height. So to find the base right here, it's going to be opposite of 47 over 5 is the hypotenuse. So opposite over hypotenuse is the sine. So the sine of the angle, sine of 47, equals opposite over hypotenuse. Cross multiply, sine 47 times 5, that's going to get you the base, which is 3.66. 3.66. Now notice, class, that just got you this right here. So the base of the whole triangle is twice as much as the 3.66. So let's double it, multiply it by 2. So 3.66 times 2, the base is 7.31. All right, now we also have to find the height of the triangle. This height right here, so to find the height, it's going to be adjacent over hypotenuse. So the cosine is adjacent over hypotenuse. The cosine of 47 degrees equals opposite equals adjacent h over hypotenuse 5. So when you cross multiply these, cosine 47 times 5, you get 3.41. 3.41. Okay, so we did all this to find the area of the triangle. The area of the triangle is 1/2 base times height. The base, 7.31. The height, 3.41. What a day, what a day. So we multiply all three of those together, and the height of the area of the triangle is 12.47, roughly. 12.47. So what's the area of my segment? If the whole thing is 20.51, and the area of the triangle is 12.47, I would subtract the two. 20.51, subtract the 12.47. The area of that segment is approximately 8.04, and these are in square centimeters. centimeters squared. And our last one for today. This one, it says find the area of the shaded region, so very similar to the last one. The hexagon is inscribed, and it's a regular hexagon with a diameter of 12 centimeters. So what we're going to do here, class, is I'm going to draw this sector, and I'm going to find the area of the green segment, just like I did on the last problem, and then I'm just going to double it because the area of this segment is congruent to the area of this segment. Because a regular polygon, all of these sides are congruent. We learned last chapter in chapter 10 that when a chord is congruent, the corresponding arc is also congruent. So those two segments would be congruent. All right, so if we know that the diameter is 12, then the radius is 6. And then we know that in a hexagon, 360 divided by 6 triangles is 60 degrees each. So that means this arc measure is 60 degrees. So the area of the whole sector is n over 360, 60 over 360, pi radius squared. And the radius is 6. Okay? So when we do 6 squared, that's 36. 36 times 60 over 360 times pi. We'll just keep our answer in terms of pi on this one. We get 6 pi. 36 times 60, 3/60 is 6. So 6 pi is the area of the whole sector. Now we want to subtract again the area of this triangle. So the area of this triangle, when I draw the height right here, that cuts the angle in half. So now everybody, we have a 30, 60, 90 right triangle. So the base and the height are a little bit easier to find on this one. If the hypotenuse is 6, then the shortest side is half as much. That one's 3. And then the radius, the height of the triangle is the square root of 3 longer than the shortest side. So 3√3. So what is the area of this blue triangle right here? Area equals 1/2 times the base, and the base is 3 plus 3, which is 6. Times the height. The height is that 3√3. So half of 6 is 3, and 3 times 3 is 9√3. So the area of the triangle is 9√3. So the segment is the sector minus the triangle. 6 pi minus 9√3. And that is the area of this green segment. And we want 2 of them, right? So we're going to multiply it by 2. So in exact answer, the area of the shaded region, the 2 segments, is 12 pi minus 18√3. It's always kind of nice to have an approximate answer as well, because sometimes 12 pi minus 18√3 doesn't mean as much as approximately 6.52. And our units, again, are in centimeters. So square centimeters. All right. I hope that this lesson made sense. If you have any questions, please let me know. Enjoy your day, everybody. We'll see you later.